Hello everyone. So today we're going to go over section 6.4, multiplying improper fractions and mixed numbers. So we'll begin by looking at how to find the area of a rectangle. So as we recall, the area of a rectangle is equal to its length multiplied by its width. Okay, so usually we label a rectangle with L and W for length and width respectively. Now we'll be using the area model to find the product of mixed numbers and improper fractions. So let's look at this first example. We are looking at 1.5 multiplied by 2. So the square on the left has area of 1. It is 1 by 1. And on the diagram on the right, we have a length of 2. That's 1 and 1, which added together makes 2. And a width of 1.5. So here we have 1 and then 1/2. What this allows us to do is to find the area of each individual part. So for example, we have 1 times 1, which makes this area 1. 1 times 1 again, so this area is also 1. And finally, we have 1/2 and 1/2 as the areas of the bottom two rectangles. So what we actually did here is we multiply 1.5, which is on this left-hand side here, the width, by 2, which is the length of this area. And of course, the area of the whole product, so 1.5 multiplied by 2, is equal to the sum of each individual product in the four individual pieces that we have. That's 1, 1, 1/2, and 1/2. So in other words, 1.5 multiplied by 2 is equal to 1 plus 1 plus 1/2 plus 1/2, which is equal to 3. Okay, which also makes sense since we have an area of 1, 2, and then these two halves added together would make it 3. Okay, so let's look at now an example with more than just one mixed number. We have 1.5 times 1 2/3. So in this case, we once again start with the square of area 1 on the top left. And each one of these is 1/3. So this top side has a length of 1 2/3. And on the other side, we have 1.5. So in order to find the product of 1.5 and 1 2/3, we can look at this area model and add up all the individual areas that we see. So again, 1 times 1 is 1. And here in this rectangle, we have 1 times 1/3, which is 1/3. And a second 1/3 here. And then we have 1/2 times 1, which is 1/2. And finally, on the bottom right, we have 1/2 times 1/3, which is 1/6. And another 1/6. So what that means for us is that if we're looking at 1.5 times 1 2/3, we have the following areas to consider. We have 1 plus 1/2 plus 1/3 plus 1/3 plus 1/6 plus 1/6. Now we will need to add the fractions together using a common denominator of 6. So instead of 1/2, for example, we have 3/6. And of course, the 1/3 would be 2/6. And again, 2/6. And finally, 1/6 here, and another 1/6. And now we can add the numerators together since the denominators are all the same. So we have essentially 1 and 9 over 6, which would be rewritten as 2 and 3 over 6, and finally reduced to 2.5. Okay, which also makes sense if we look at the area model. These two areas of 1 over 6's can be made into 1/3, which makes this 1 here. So we have 1, 2, 1, 2, and then a half. So that is indeed the product. Okay, just one more with the area model. And the idea here is that we don't necessarily need to draw the diagram to scale. So what we can do instead is something like this. So here we have 3 and 2 over 3. So the whole number and fraction components of this mixed number, and also 2 and 1/2. So we're going to go ahead and find out the area of each one of the 4 corners. So starting with top left, 2 times 3 is 6. And then we have 2 times 2 over 3, which is 4 over 3. 1/2 times 3 is 3 over 2. And finally, 1/2 times 2/3 is 2 over 6. So now we can add these 4 together to find out the product. And that is 6 plus 4 over 3 plus 3 over 2 plus 2 over 6. Once again, as before, we were looking for a common denominator. In this case, it would be 6. So this is 8 over 6. This is 9 over 6. And 1 over 6. So in the first fraction, we multiply by 2 over 2. And the second fraction, we multiply by 3 over 3 to get the common denominator. All right, so now we can add together the numerators, which makes 18. So we have 6 and 18 over 6. Oh, sorry. Wait, this is not 1 over 6. This is 2 over 6. Sorry about that. That is error on my part. It's 2 over 6. This is 2 over 6. Right, so it actually adds up to 6 and 19 over 6. That's better. So once we write this into a proper mixed number, we actually get 9 and 1 over 6. And that's it. So the idea is we don't necessarily want to draw an area model every time we multiply mixed numbers together or improper fractions together. So we're looking for maybe a quicker way. So let's look at converting mixed number into improper fractions. That will also help because then we only have to deal with one type of multiplication instead of mixed number and also improper fractions. So recall that 3 and 1/5 is the same as 1 plus 1 plus 1 plus 1 over 5. So the idea here is that we have just 5 over 5 plus 5 over 5 plus 5 over 5 plus 1 over 5. Since each one can be rewritten as 5 over 5, and this can be rewritten as, this can be added together into 16 over 5. Okay. Alternatively, we can simply take 3 multiplied by 5, 3 being the whole number component, and 5, of course, being the denominator, and then we add the 1, which is the numerator in this case. So we add 1 here, keep the denominator, and 3 times 5 is 15. 15 plus 1 is 16, so we also get 16 over 5. And of course, the second method is a little bit quicker. All right, So, likewise, in the second page, we have some more examples of finding improper fractions. So, in the first case, 2 times 4 is 8. 8 plus 3 is 11, so we have 11 over 4. In the second case, 3 times 7 is 21, so this is 21 plus 2 is 23 over 7. And finally, 5 times 9 is 45, plus 4 is 49 over 9. Okay, so again, that is 2 times 4 plus 3 is equal to 11 in the first case. In the second case, we went 3 times 7 plus 2, which is 21 plus 2, which is 23. And finally, in the last case, we have 5 times 9, which is 45, plus 4, which makes 49, the numerator. Okay, so next up, just a quick reminder on estimating products. As we saw before, we estimate each fraction as either 0, 1/2, or 1. So in this case, 6 over 7 is closer to 1 than it is to 1/2. So 2 and 6 over 7 can be estimated to be 3 multiplied by 5. So that would be approximately 15 or close to 15. That's a reasonable estimate. In the second case, 15 over 7, right? So 7 times 2 is equal to 14. So 15 over 7 is close to 2. 8 over 9 is close to 1. So here a estimate would be 2 times 1, which is 2. In the third case, very similar. So 8 times 2 is 16. So 17 over 8 is close to 2. And the second part here, 5 over 6 is close to 1. Plus 3 makes 4. So the product here is a reasonable estimate would be 4 times 2, which is 8. Okay. So with that in mind, the next piece is to learn about multiplying fractions without models or diagrams, just in general. So here, there are 3 steps. Step 1 is to change to improper fractions. Second part is to multiply, so numerators are multiplied together and then denominators are multiplied together. And the third step is to reduce and rewrite. And of course, as before, if it is possible to reduce before multiplying, then that's generally a good idea to keep the number smaller and rewrite as a mixed number. Okay, so let's look at some quick examples here. So 4 times 2 is 8. 8 plus 1 is 9. So this is 9 over 2 times, and then 2 times 3 is 6. 6 plus 1 is 7. 7 over 3. And as always, we will try to reduce before multiplying. So in this case, notice that both 9 and 3 are divisible by 3. So we're left with 3 and 1. And then we can multiply together 3 times 7, which is 21. And 2 times 2 times 1, sorry, is 2. So then we can rewrite this as a mixed number at the end, and then 10 and 1/2. Okay. Similar in the second example, 1 times 14 is 14. 14 plus 1 is 15. So this is 15 over 14 times 2 times 3 plus 1. So just like the last example, we have 7 over 3 again. In this case, however, 15 and 3 can be reduced to 5 and 1. and 7 and 14 can be reduced to 1 and 2. And then we can multiply these together. 5 times 1 is 5. 2 times 1 is 2, of course. And we can rewrite this as 2 and a half. Okay. Let's a couple more. So in the next case, 3 times 5 plus 1 is 16. So this is 16 over 5. And in the second fraction, we have 3 times 8, which is 24, plus 1 is 25 over 8. Just as before, 16 divided by 8, or 16 and 8 are both divisible by 8. And also 5 and 25 are both divisible by 5. So notice that in this case, we have 2 times 5 for our numerator, which is 10. And the denominator is simply 1. So this is just 10 for our final product. Okay, one more. So here we have, in this case, 5 over 3. And also 7 over 5. In this case, the 5s are both divisible by 5. Oh, sorry, this is not 7. This is, right, 2 times 5 is 10. 10 plus 1 is 11. Sorry about that. So yeah, so then we can multiply these together. This will give us 11 over 3, which is also 3 and 2 over 3, since 11 divided by 3 gives a quotient of 3 and a remainder of 2. Okay, so finally, just a couple of quick word problem examples. The number of hours in 3.5 days. So in this case, we're looking at 24 hours per day multiplied by 3.5 days. Then we can rewrite 3.5 as 7 over 2. Of course, here 24 and 2 are both divisible by 2. Left with 12 and 1 here. So simply then the product is just 12 times 7, which is 84 hours. Okay. One more. Driving distance from Winnipeg to Regina is 570 kilometers. Driving distance from Winnipeg to Calgary is 2 1/3 times the driving distance. What is that distance? All right, so very similar to last example, we have 570 times 2 1/3. So we are going to rewrite 2 1/3 as a improper fraction. So that will be 7 over 3. Notice that 570 is divisible by 3, which gives us 190. And so finally, the product of 190 times 7 is going to be 1,330 kilometers. All right, so that is it for multiplying improper fractions and mixed numbers. First with the area model for mixed numbers, and then without any models, just changing everything to improper fractions, multiplying, and then reducing afterwards. Also cover some estimating once again, and that's it for today, so thank you for listening.